66 million years ago, the dominant life forms on Earth disappeared within a geological instant. The non-avian dinosaurs, creatures that had ruled terrestrial ecosystems for over 160 million years, vanished from the fossil record. What force was powerful enough to end an era of such evolutionary success? And what does their extinction reveal about survival, adaptation, and the fragility of even the most dominant species? To understand how dinosaurs went extinct, we must first recognize what they were. Dinosaurs were a diverse group of reptiles that first appeared approximately 230 million years ago during the Triassic period. They evolved into an extraordinary variety of forms, from massive herbivores like Brachiosaurus to apex predators like Tyrannosaurus rex. Evidence suggests they dominated terrestrial environments across every continent. Their evolutionary success was remarkable. For over 160 million years, dinosaurs adapted to changing climates, evolving specialized features for feeding, defense, and reproduction. They ranged from chicken-sized creatures to animals weighing over 70 metric tons. Some developed feathers. Many were likely warm-blooded, challenging earlier assumptions about reptilian metabolism. But evolutionary dominance does not guarantee survival. The extinction of the non-avian dinosaurs represents one of Earth's 5 major mass extinction events. Understanding what happened to them provides crucial insights into how catastrophic environmental change affects even the most successful species, lessons that remain relevant to human survival and our understanding of adaptation under extreme pressure. The leading scientific explanation for dinosaur extinction centers on a catastrophic asteroid impact. In 1980, physicist Luis Alvarez and his son, geologist Walter Alvarez, discovered an unusual layer of iridium, a rare element on Earth but common in asteroids, in rock formations dating precisely to 66 million years ago. This iridium layer appears in geological records across the planet. The smoking gun came in 1991 with the discovery of the Chicxulub crater, buried beneath Mexico's Yucatan Peninsula. This impact structure measures approximately 180 kilometers in diameter. Research indicates the asteroid that created it was roughly 10 to 15 kilometers wide and struck Earth with the energy equivalent to billions of atomic bombs. The immediate effects would have been devastating. The impact likely generated massive earthquakes, tsunamis hundreds of meters high, and ejected trillions of tons of debris into the atmosphere. Evidence from rock samples shows a layer of shocked quartz and spherules, tiny glass beads formed from vaporized rock, consistent with an extraterrestrial impact of enormous magnitude. But the impact itself was only the beginning. The long-term environmental consequences would prove even more lethal to dinosaur populations worldwide. The Chicxulub impact triggered a cascade of environmental catastrophes. Scientists broadly agree that massive amounts of dust, ash, and sulfur aerosols were injected into the atmosphere, blocking sunlight for months or potentially years. This phenomenon, sometimes called an impact winter, would have caused global temperatures to plummet. Without adequate sunlight, photosynthesis largely ceased. Plant life died on a massive scale, collapsing food chains from the bottom up. Herbivores dinosaurs would have starved first, followed rapidly by the carnivores that depended on them. Fossil evidence shows a sharp decline in plant diversity at the boundary layer between the Cretaceous and Paleogene periods. Research indicates that wildfires ignited across the planet from superheated debris raining back down through the atmosphere. Chemical analysis of the boundary layer reveals soot consistent with global combustion. Ocean ecosystems suffered similarly. Marine reptiles, ammonites, and many species of plankton disappeared from the fossil record at this time. Survival during this event depended on specific characteristics. Animals that could shelter underground, those with modest food requirements, and species capable of entering dormant states had better chances. The extinction was selective but devastatingly effective against large-bodied animals with high metabolic demands. The extinction event killed approximately 75% of all species on Earth. Yet, life survived. Understanding what separated survivors from victims reveals fundamental principles about adaptation and resilience. Birds, technically a lineage of dinosaurs themselves, survived the extinction event. Evidence suggests their smaller body size, lower metabolic needs, and possibly their ability to fly to locate scattered resources gave them crucial advantages. Similarly, mammals, most of which were small and many of which lived in burrows, weathered the catastrophe. Crocodilians survived, likely due to their ability to fast for extended periods and their aquatic lifestyles, which buffered them from the worst atmospheric effects. Turtles, with their slow metabolisms and omnivorous diets, also persisted through the crisis. In contrast, large dinosaurs, despite their 160 million years of evolutionary success, were too specialized for the world that existed before the impact. Their size required enormous food intake. Their ecosystems were too complex to reassemble quickly after the collapse. Evolutionary success in stable conditions became a liability during rapid catastrophic change. This pattern appears repeatedly in extinction events. Adaptability and resilience matter more than dominance. The most powerful predator and the largest herbivore both disappeared, while small, opportunistic survivors inherited the Earth. The lessons from dinosaur extinction extend beyond paleontology. Research into this event has fundamentally shaped how scientists understand vulnerability, adaptation, and the relationship between species and their environments. Modern humans face no immediate asteroid threat of similar magnitude. Detection and potentially deflection technologies are being developed for such scenarios. But the extinction of the dinosaurs demonstrates how rapidly dominant species can disappear when environmental conditions change catastrophically. Evidence from the Cretaceous-Paleogene boundary reveals that ecosystem complexity can become a vulnerability. Specialized species with specific habitat requirements and intricate food web dependencies suffer most during rapid environmental shifts. In contrast, generalist species with flexible diets, broad habitat tolerances, and modest resource requirements show greater resilience. Human survival has historically depended on precisely these generalist traits: our adaptability, our omnivorous diet, our ability to modify behavior and create tools rather than relying solely on physical specialization. Yet modern human civilization has created unprecedented dependencies on complex systems, global food supply chains, technological infrastructure, and specialized knowledge. The question worth considering is whether our current trajectory resembles the adaptability that has characterized human evolution, or the specialization that made dinosaurs vulnerable when their world changed. 66 million years ago, the Chicxulub impact ended the age of dinosaurs. The non-avian dinosaurs, creatures that had successfully adapted to countless environmental changes over 160 million years, could not survive the rapid, catastrophic alteration of their world. Their extinction was not inevitable. Had the asteroid struck a few million years earlier or later, the outcome might have differed. Had it impacted different geology, releasing fewer sulfur aerosols, the environmental effects might have been less severe. The fossil record suggests dinosaurs were already experiencing some stress from volcanic activity and climate shifts, but evidence indicates they remained diverse and widespread until the impact. What remains certain is that dominance does not guarantee survival. Size, strength, and evolutionary success measured in millions of years offered no protection against a threat that fundamentally transformed the entire planet in a geological instant. For our own species, the lesson is not one of fear, but of perspective. Humans have survived ice ages, volcanic winters, droughts, and migrations into every environment on Earth. Our ancestors persisted through conditions that eliminated countless other species. That survival was built on adaptability, cooperation, innovation, and the capacity to change behavior rapidly when circumstances demanded it. The dinosaurs teach us that no species, regardless of its dominance, is immune to extinction, but they also reveal that survival belongs to those who can adapt to change, even catastrophic change. As we shape our future, understanding our past and the past of life on Earth may prove to be our most valuable tool. The asteroid that ended the Cretaceous period fell from the sky without warning. The challenges we face today are visible on the horizon. The difference is the opportunity that visibility provides, if we choose to act on it.